For over a century, astrophysics has taught us a terrifying truth. There are monsters in the dark. Black holes, the ultimate end of the line. A gravitational trap so deep, so absolute, that not even light, the fastest thing in the universe, can escape its grip. We view them as eternal prisons, the permanent garbage disposals of the cosmos. Whatever falls in is gone forever. But there is a flaw in that story, an error in how we perceive the universe. Because in physics, true permanence is an illusion. Even the darkest, most massive objects in the universe are not immortal. They are bleeding, slowly, invisibly, over timescales that shatter human comprehension. They are evaporating. Black holes are dying. And to understand how a void can bleed to death, we have to stop looking at the black hole and start looking at the empty space around it. We think of a vacuum as empty space, nothingness. But quantum mechanics tells us a different story. Space is never truly empty. It is a boiling ocean. At a microscopic level, pairs of particles are constantly popping into existence. A particle and its antiparticle. They appear from nowhere, borrow energy from the universe, exist for a fraction of a millisecond, and then crash back into each other, vanishing entirely. This happens everywhere, all the time. In the room you are sitting in the space between galaxies. Nature balances her checkbook. The energy is borrowed and instantly returned. But what happens if this occurs exactly on the edge of a black hole? The event horizon, the point of no return. Imagine a pair of particles appearing right on this razor-thin boundary. Before they have a chance to collide and annihilate each other, one of them falls in. The other escapes. The partnership is broken. The debt to the universe was not paid. But the laws of physics demand that energy cannot be created out of nothing. Someone has to pay the bill for that escaping particle. And the universe forces the black hole to pay. The black hole gives up a microscopic fraction of its own mass to create that escaping particle. This is Hawking radiation. Particle by particle, atom by atom, the black hole is bleeding its mass into the void. It is a cosmic leak that cannot be plugged. But this bleed is excruciatingly slow. For a supermassive black hole, the radiation is so weak it is practically non-existent. Right now, black holes are absorbing far more mass from stars and gas than they are losing through evaporation. To witness their death, we have to travel forward in time, far beyond the lifespan of the Earth, beyond the death of the Sun, beyond the end of the last star. Welcome to the black hole era, trillions upon trillions of years from now. The universe is dark, it is freezing, the galaxies are dead. The only things left in the cosmos are black holes, wandering in absolute silence. There is no more gas to eat, no more stars to swallow. Now the scales tip. The bleeding becomes the only process left in the universe. The time it takes for a supermassive black hole to evaporate is a number so large it breaks the human mind. A Google years. That is a 1 followed by 100 zeros. If every atom in the known universe represented 1 billion years, you would still run out of atoms before the first supermassive black hole dies. But time in a dead universe is abundant. And as a black hole loses mass, something strange happens. The smaller it gets, the hotter it gets. The hotter it gets, the faster it bleeds. A process that took a Google years to start suddenly accelerates into a violent sprint. In its final millennia, it is no longer a dark, silent observer. It is a blazing sphere of heat. It shrinks to the size of a mountain, then a boulder, then a speck of dust. As it reaches the size of a subatomic particle, The mathematics of gravity break down entirely. The temperature reaches absolute limits. It cannot hold itself together anymore. It dies in an unimaginably violent flash. An explosion with the force of billions of nuclear bombs, tearing through the silent dark. A final scream into the void. The great destroyers of the universe do not end in darkness. In their final fraction of a second, they give all their stolen energy, all their captured light, back to a dead cosmos. Nothing is eternal, not even the dark.